I'm Mike Schnecker, Business Development Manager at Rohde Schwarz. I'm going to talk about testing for a new high-speed automotive Ethernet standard called Multi-Gigabit Ethernet. Here we have a setup with a evaluation board. It runs up to 10 gigabit per second, 10G base T1 is the standard. And we've got it set up in a test mode where it's transmitting a random data pattern. And on the oscilloscope, we're measuring that data pattern. So I essentially have the twisted pair interface connected to two cables, connected to channels 1 and 3 of the scope. In the instrument, we're actually doing a subtraction of the two plus and minus wires in hardware. So we're actually creating a differential signal, which we're showing on the screen here, and the common mode signal is actually minimized and being shown there, so we can actually see both differential and common mode responses on the same display. One of the other things I'm doing is I'm actually generating an I pattern. Now the key thing about generating an I pattern is you need some sort of a reference clock to do that. So on the RTP164, which is the instrument we're using here, we're able to recover that clock from the data signal. And in this case, it's actually a multi-level signaling. It's a PAM4 signal, so there's 4 signaling levels, as you can see. And the clock recovery is able to lock onto the crossing point here in the middle. We set up the clock recovery in the trigger setup. So in here we have it set up as a serial pattern trigger using hardware clock recovery, and I put in the nominal symbol rate for this standard, which is 5.65 gigabits per second. And so the instrument is locked to that clock, and so we're observing now the I pattern. And once you have the I pattern on display, we can see a general overview of the signal integrity, which is really important because it allows you to see both jitter and noise at the same time, and it allows you to actually measure an active interface, so you actually don't need any special test modes to do this. We're measuring a couple of key measurements. We're measuring eye height, which is the inner amplitude within the eye, and we're measuring the eye width, which is the inner amplitude horizontally across the eye. These are two key parameters. Eye width tells you about timing uncertainty, and eye height tells you about the noise level. There's many other measurements we can do as well, including some compliance tests, but we'll leave it for this particular demo. For more information, check out www.rohde-schwarz.com.